I don't know. I can't think of any other machine shop where it's just one bloke who can find the time to box up all of his fasters and label them.
He's organised.
This mill, this is an old, much older Herco. It's got a version 8 control and 9 control.
No, it was 8, but he's upgraded to 9.
Which I absolutely love.
Without breaking it.
Yeah,
Whoops.
exactly. So he machined
his
his own soft jaws with his own little teeth on them. So actually, he's a methodical worker. He knows exactly what he's doing, and he's imaginative as well.
Modular system, they can take them off, put them back on, saving the company hundreds, if not thousands of pounds. Great solution.
Yeah, exactly. Small machine, but as standard, you get tool measurement system, parts catcher, 12 tools, and also, what is he like?
He'll be here all day. Well, what are the engineers like? You've used these before, haven't you?
No, I've not. Of course, that's the one control I've not used.
Okay, but a lot of engineers, we see this regularly. What do they like about these controls?
Well, they're conversational, they're really easy to use. Obviously, lots of other controls are conversational as well, but these are really easy to program. Bit similar to the shop mill, but honestly, Steve said he absolutely loves these controls.
Another 10-minute tour, but it's not a tour, play on words, it's a 10-minute story. Get it?
Story, yeah, okay, yeah, we're going to tell a little bit of a story about Steve's workshop here at...
You're going to tell it, I'm going to tell it, I'm going to ask you the question.
All right, sorry, yeah.
I've got to work with, but great machine shop up in Wales. We've got a pun coming about Wales soon, but you like old machines, you like new machines. Let's go to the old machine first. Jones and Shipman, but what is it?
So this is an OD and an ID grinder. This here is a linear drive, so it goes, this does ODs, and also if you turn it around, you've got a little ID grinder here.
Nice and simple. It's got a leak, that's why we're in Wales.
Yeah, exactly.
That was my gag, thank you very much.
Didn't get that about 10 minutes ago.
Okay.
But what I like about it, it's also got new linear scales fitted to it and a nice DRO. Obviously, it's been maintained right now, but still really accurate.
An oldie but a goldie, not
Exactly.
me, the machine. Now, classic example of what Steve does do is come up with solutions. These parts down here, relatively simple, but they go on the back of trucks, don't quite know where, part of the weighing system, but the modular system, they can take them off, put them back on, saving the company hundreds, if not thousands of pounds. Great solution. And we're going to see that. It's a bit of a theme about coming up with solutions. Right, next machine, an XYZ. Tell me all about it.
So it's a nice XYZ standard VMC. They've been making these for years. These are absolute workhorses of a machine. What I like about them is the seamless control. Shop mill, it's great for programming fixtures and stuff online, but he doesn't just program online controls, does he?
I don't know.
No, he doesn't. He uses Hypermill as well.
Oh, there you go. So absolutely, and the components he's making great components before, even better, gone to the next level. We'll look at those in a while. But one thing about this, did you know? Holding tolerances, same as brand new machines.
Right.
And I don't know how old it is, not as old as me.
Not quite.
So it's probably the 90s, not the 80s. Anyway, moving on. Another XYZ. Tell me about this, an XYZ lathe.
So we've got an XYZ Proto-Track lathe, which I've never used a Proto-Track before, so I don't quite know the difference between this and a full CNC lathe, but looking at it, it's fairly well built, but it looks like a manual on the inside, but we've got almost a CNC control on the front with the Proto-Track.
Well, a little story, and I will tell you a little story because I like those, is I've been out before and people have bought these machines, time-served engineers doing their manual machining, turning. I don't want to use these CNC things, you know, these newfangled things. They got them on the Proto-Track, guess what? Can't get them off, absolutely love it. So it's a great endorsement of the XYZ machines. Obviously these are older machines, they've got a great range of machines. Now come on, let's go. Next machines.
Yep, Hercos.
Whoa.
So we've got two Hercos here. This is a new one from 2019.
2019 or 2020?
2020?
We're not going to have a dust up, we had a dust up off camera earlier.
I don't know. So this is, what I like about this, standard fixed head lathe, but 350mm diameter OD, so you can do big parts on this. And also, I think it's half a meter, I can't remember if it's a half a meter or a meter in the Z. I can't quite remember, but big Z travel as well.
Big Z, especially compared to the size, the footprint of the machine.
Yeah, exactly, small machine, but as standard you get tool measurement system, parts catcher, 12 tools, and also, what is he like?
He'll be here all day. Well, what are engineers like? You've used these before, haven't you?
No, I've not, of course. That's the one control I've not used.
Okay, but a lot of engineers, we see this regularly. What do they like about these controls?
Well, they're conversational, they're really easy to use. Obviously, lots of other controls are conversational as well, but these are really easy to program. Bit similar to the shop mill, but honestly, Steve said he absolutely loves these controls.
Okay, so if I want to make a quick part, maybe a fixture or something like that, pop it on there, done and dusted, so I don't need the full pro.
Yeah, so simple round parts on turning, simple square parts with lots of drilled and tapped holes, reams, which it's just not worth bulling in the model, setting up the stock and hypermill or whatever your CAD
Just
CAM
get a
system
Herco
is.
with a...
Just get on a Herco and bang it out.
Okay, now a slightly older Herco, and this those eagle-eyed amongst you will spot it is a mill. Tell me a little bit about this mill.
So this mill, this is an old, much older Herco. It's got a version 8 control and 9 control.
No, it was 8, but he's upgraded to 9.
Is it? Okay, so he's upgraded the control. So we're still using the WinMax control, a little bit smaller screen there, but he's still running this machine day in, day out. This is a meter traveling the X, so he needs this if he's going to be doing big parts like what we're looking at right here.
Like I say, huge working envelope there. And that is the first op or second op on a fantastic component.
That's up 2.
Op 2, there you go, I stand corrected. But big spindle, nice, powerful, big chunks of metal. Light metal here though, aluminium.
Yeah, aluminium. It's an automotive grade aluminium, so probably 7,000, 8,000 series. But still, even though it's aluminium, it's still a tough part of the machine.
I want to stop you there. Do not focus on this yet, Ian. Back off. We'll come to that in a minute because these are some fantastic parts. And when you came here, it is a one-man machine. Well, 4 machines or 4 newer machines, a couple of older ones. You were just blown away by the
I was.
If I could say components.
Yeah, well, it's not just the engineering I love, which is obviously fantastic with the tools he's making himself, but it's just the cleanliness of the shop, the engineering management as well, which you might go to some places that are full of people who absolutely, they know exactly what they're doing, they know their stuff, but he's even got boxes to hold all his fasteners in. Like, I don't know, I can't think of any other machine shop where it's just one bloke who can find the time to box up all of his fasteners and label them.
He's organised. So let's talk about some of the parts. And it's yes, the parts, but it's also the solutions and just thinking outside the square or outside the mill or the lathe. So first ones, these parts here. Now these are turn parts. But
yeah. So these are actually really quite simple parts, aren't they? It's just a couple of ODs, one little bore, little counter bore with a.
We practiced this earlier and Jerome can't get it out.
I think I might have screwed that. Yeah. So it's all it's got is a little hole and a taps with a thread in it. But obviously, if you're machining that, you've got to machine, I guess, from that side, part it off, take it out, either stick it in a mill. You could either mill the bore out, or you can stick it back in the lathe. And it'd take a long time just to make that.
You're going to lose your accuracy as well, aren't you? If you're taking it in and out.
And you are, yeah, but you'd have to probably do it in 2 ups anyway.
Yep.
But what you probably do is you'd have to go mill and drill, or drill and tap even.
Drill and tap. So three tool changes per component.
So there's lots of tool train changes. But instead, if you put all of these in this really nice looking fixture, you're instead doing 20 parts with only 3 tool changes.
Wow. So instead of 20 parts, 3 tool changes, with my basic maths, that's
60.
Boom, just 20 tool changes. So a third of the time. Brilliant. Great little solution there. Next one on.
There's so many to choose from, aren't there? These are all just examples.
I'm in charge
all
here.
right, sorry, Colin. All right.
What is that?
So normally, if you've got some soft jaws, you'd probably buy the soft jaws from a manufacturer or from the people who supply your shop. What he decided to do was get actually an aluminium billet, just machine his own, which I absolutely love.
Without breaking it.
Yeah, exactly. So he machined his own soft jaws with his own little teeth on them. So actually, he's a methodical worker. He knows exactly what he's doing, and he's imaginative as well.
Yes. Yep. Coming up with a great solution. And talking of solutions, so that's part of a clutch setup.
Yeah. So I think these finger clamps that
the
clamp.
Clamps.
Yeah.
Part
so
of a clutch.
Yeah, something like that.
Okay. Right. Next. Now this is great. What is that?
So this is a homemade face mill. I say homemade.
You say homemade.
It's handmade. It's precision engineering. Homemade. It is homemade. This is his home. He works here. He doesn't live here. But what I love about this is also he's chosen. So normally this is for skimming an engine block head. There's I think loads of people know why you need to skim an engine block head with very precise tools.
Why then? Just to clarify.
Well, so this is an engine block. The engine block head. So the engine head, sits on top of this. This is the engine block. And you want this to be as flat as possible, partly because this is going in a motorbike. It needs to be balanced because the motorbike is highly tuned for motorsport. But also, you need to make sure you get a good finish on this with no lines. Because if you do this in multiple passes with a smaller face mill, you get lines, meaning you don't quite get such a good seal. And there's quite high pressure in these cylinders, as you can imagine, because they're blowing. And also, because you've got coolant in this water jacket here. So you need a good surface. You need to do it in one pass. So you need a big face mill. B, big face mills generally have lots of teeth. So all those inserts, you might have an 8-tooth, 12-tooth face mill. All those inserts are actually at slightly different Z heights. So
why don't you just buy that from a catalogue?
I don't know, maybe because it's a bit expensive or because you probably just only get a big face mill with only one insert. With this you can get 2, they're adjustable so you can set the Z heights, make sure you've got
brilliant, right. We've chatted a lot, we need to move on quickly.
Well, you did ask me about it.
No, I did. No, it's great. So what's he doing here very quickly?
Okay, so he was boring out here these cylinder bores.
He's always been interesting.
Sleep, he is. So he was boring out these cylinders, which is a gorgeous finish, I've got to say. But before, he was getting chatter just using this boring bar. So this is just a standard.
I'm getting too much chatter right now. Quick.
Sorry. So he just basically designed and made these 2 little bits to support the boring bar.
Great solution. motorsport parts all along here. He's only got a 3-axis machine, but like you said earlier, wow, that's a 5-axis part.
It is, yeah. So you'd probably want to stick this on a rotary table or a 5-axis machine just to index round and achieve all of those parts, all of these features. So there's a bore in there that needs to be accurate to another bore here.
Right here.
Yeah, all right. Sorry. I'm just getting excited because I love what Steve's doing here, and I could talk for hours about all of this.
We know.
Anyway, sorry. All right. So I'll try and be quick. But he's instead done this on a 3-axis machine in I don't know how many setups, about 4 or 5 different setups. There's loads of complex features on here and really tight tolerances that he's still hit because he's got complex.
Two
he's
more
got good
things, and
fixturing.
very, very quickly. This doesn't come easy. CAD CAM.
CAD CAM, yeah. So he's using Hypermill. He absolutely.
It's a 1-man, 2 mil machine shop though. Is it cost effective?
I mean, most people would assume that Hypermill is an expensive option, and you can only really use it if you have lots of machines and a lot of capital to play with. But it's just Steve. He's just running 2 CNC machines, well, 3 CNC machines. He can still afford Hypermill.
Okay, last but not least, there was an issue with machining this. He didn't initially want to do the job, but there was quality issues from the overseas supplier and things like that. What were the issues with this, and what was the solution? I don't want to push you too much, but very.
You're asking me, in my opinion, if I saw this, if the customer sent me the model of this, I'd think, first of all, oh my God, look at the size of that slot and look how deep it is. That's a 6 mil slot by 50 mil deep.
Okay.
I think, I've machined slots like this that are 15 mil deep, 20 mil deep, 6 mil wide, and I've got chatter to any, that's just awful, absolutely looks terrible. He's got 50 mil deep. So he went to Quick Grind, they supplied him with a solution, some special tooling here.
I'm not allowed to touch this because I broke it earlier.
Yeah, you broke it earlier, exactly.
But you're going to get big run out in that sort of length, aren't you?
Not necessarily, not if you've got a good, obviously Quick Grind make good tools that ground to good concentricity. If you've got so they've got Centro P holders here, which obviously have fairly good run out from Ceratizit.
What was the other issue then?
And also, so this is a little clearance hole for, I guess, the cam chain.
Yep.
And this has an issue because it's got, basically, rather than just being a standard 3-axis feature, you've got tapers on both sides, so you have to actually scan that out. Now, he's still working on the finish on this side, unfortunately, but Quick Grind helped him again with a...
So Mark, we need to drop a name there. Was it Mark Aspinall, is that correct?
Yeah, the sales guy, I think. Yes,
yeah,
like that.
Looking at me. So Mark Aspinall, Quick Grind. He couldn't find these in any catalogue, so he went to Mark, can you provide me with a solution? But can you provide me with a quick solution?
From Quick Grind.
And a cost-effective solution.
Yep.
Absolutely, yes and yes. There you go. So these are solutions for that. So it's all about bringing your partnerships together. Your XYZ, your Hercos, your
Ceratizit.
Yeah, your Open Mind, Ceratizit, and your Quick Grind. Bring it all together, making fantastic components like this. Have you enjoyed this 10-minute story?
Absolutely love it. I've just noticed actually there's probably about 6 partnerships and just one guy.
Brilliant. Absolutely love it. Steve Rigby, HSM Components, and all his partners. Absolutely brilliant.